Hey everyone, and welcome to this explainer. Today, we're going to embark on a super fascinating journey to build the ultimate tech family tree. We're going to strip away all the complicated jargon and really demystify what a computer truly is at its core. Whether you consider yourself a total tech novice or a seasoned expert, I promise you're going to see the digital world around you in a completely different light by the time we wrap up. But first, I want you to consider a kind of surprising question. What do an old-school mercury thermometer and that shiny desktop PC sitting on your desk actually have in common? I mean, at first glance, absolutely nothing, right? We've all been heavily conditioned to think that a computer absolutely must have a glowing screen, a keyboard, and, a Wi-Fi connection. But today, we're going to completely shatter that preconceived notion. So here's our roadmap for this explainer. First, defining the computer. Second, how computers handle data. Third, computers scaled by size. And finally, the pioneers and trivia.
All right, let's dive right into section 1, defining the computer.
The word computer literally comes from the English word compute, which quite simply means to calculate. At its absolute foundational level, a computer is really just an electronic machine that helps process data to solve problems. That's it. That's the whole shebang. It's an electronic problem solver. And because problem solving is a universal human need, these machines are utilized in literally every conceivable field, from advancing medical science and cutting-edge research to publishing, design, and even just running things right inside your own home. And this brilliantly illustrates our entire blueprint for the taxonomy of tech. Think of our tech family tree as being divided into two main branches. Over on the right, we categorize computers based on their data handling capabilities, basically how they perceive the world around them. And on the left, we categorize them based on their physical footprint and processing power. So we're looking at 3 types based on data and 5 types based on size. Moving right along to section 2, how computers handle data. Fundamentally, there are 2 primary ways a machine can interpret data: analog and digital. Analog computers are designed to process continuous physical data. We're talking about data that's constantly changing and doesn't have discrete, exact values, things like temperature, electrical current, or pressure. Digital computers, on the other hand, well, those are the ones you're probably most familiar with. They take raw input and translate it into discrete binary code, just pure zeros and ones. They rely strictly on this high-speed binary input to perform calculations using programs stored right in their memory. To make this perfectly clear, just think about the devices you interact with every single day. When you glance at the speedometer in your car or check a mercury thermometer to measure body or liquid temperature, you are literally looking at an analog computer. It accepts a physical change natively without converting it into digital code. Conversely, the smartphone you might be holding right now, or your laptop, those are digital computers. They process absolutely everything through that incredibly fast language of zeros and ones to give you your final output. So the crucial point here is this. What happens when you need the best of both worlds? Well, when you combine the continuous, real-time measuring capability of an analog machine with the pinpoint memory and accuracy of a digital machine, you get a highly specialized third category, the hybrid computer. These machines are absolutely incredible because they possess the unique capability to process both discrete and continuous data simultaneously for very specialized applications. Okay, let's jump into section 3, computers scaled by size. We can actually visually step down this hierarchy, starting from the absolute largest room-sized behemoths all the way down to the device sitting right on your desk. We have supercomputers at the very top, followed by mainframes, minicomputers, personal computers, and finally, workstations. Let's explore what makes each rung on this ladder so unique. At the absolute top of the food chain, we have supercomputers. These are the most powerful, the biggest, the fastest, and definitely the most expensive computers on Earth. They possess totally unmatched processing speeds and massive storage capacity. We essentially use supercomputers for the most complex jobs our species tackles, analyzing vast amounts of satellite data, exploring the solar system, and heavy, intense scientific research. They're also the silent giants running our major financial sectors, managing global stock markets and online currencies like Bitcoin. Taking one step down, we find mainframe computers. Think of these as the tireless workhorses of major industries. They are very large machines that boast an incredibly long operational life. Their defining feature is their use of time-sharing and multitasking techniques. What that means is over 100 people can work at different terminals simultaneously on the exact same machine, and it doesn't even break a sweat. Because of this rock-solid reliability, they are the go-to choice for massive sectors like banking and telecom.
Next up, we drop down to mini-computers. Now, don't let the word mini fool you here. These are multi-user machines that perfectly bridge the gap right in the middle of our computational spectrum. Often referred to as mid-range computers, this term was originally coined for systems that needed to be substantially more powerful than a standard personal computer, but just didn't quite require the massive room-filling footprint of a mainframe. And now we arrive at the machines you definitely know best. Personal computers, or microcomputers, are designed for individuals for everyday domestic and official use. Your standard desktop or laptop containing a CPU, memory, and your basic input and output units. But alongside them, we have workstations. Think of a workstation as the specialized, highly caffeinated cousin to your everyday PC. It still serves a single user, but it's packed with unique, high-performance hardware designed to execute very specific, demanding tasks with incredible accuracy. Which brings us to our final part, Section 4, the pioneers and trivia. What's really wild is looking at the sheer scope of this timeline. I mean, it's amazing to think we've evolved from a mechanical concept back in 1833 all the way up to the 1970s supercomputer era, right through to the modern digital marvels we casually carry in our pockets today just to scroll through social media. So let's test our knowledge on this a bit. All right, time for some quick trivia. Based on that timeline we just saw, who holds the prestigious title of being considered the father of modern computers? Any guesses? The answer is British scientist Charles Babbage. Way back in 1833, which is long before electricity was even powering our homes, Babbage was the very first person to conceive of an automatic calculator. He effectively set the conceptual foundation for every single machine we've talked about today. Pretty amazing, right? Okay, next question. Let's think back to our size hierarchy. Which type of computer possesses the sheer muscle and processing speed needed to handle incredibly complex applications, like global weather forecasting and space exploration? If you guessed supercomputers, you are absolutely spot on. First introduced by Roger Cray in 1976, these absolute giants are the only machines on Earth capable of processing the monumental amounts of data required to predict global weather patterns, render complex graphic images, and run massive engineering tests. Let's throw in one last quick-fire question, this time looking at how data is handled. Which type of computer is mostly used for automatic operations? Remember those 3 types on the right side of our tech tree? The answer is hybrid computers, because they so beautifully merge continuous, real-time analog data gathering with discrete, high-speed digital precision. They are the absolute go-to devices for specialized automatic operations. We've covered everything from mercury thermometers to massive mainframes today. But here is what I really want to leave you with. As technology continually and rapidly evolves, the neat little lines we've drawn between these distinct categories are constantly blurring. I mean, the smartphone in your hand today is literally more powerful than the supercomputers of the past. So, what will the next revolutionary category of computer look like? How soon will your current digital PC become just another historical stepping stone on this tree? I really hope this explainer has sparked your curiosity to keep an eye on where the taxonomy of tech goes next. Thanks so much for joining me.